So now this video show you we're going to integral over the back side of it. So I just want purpose stop it so you can see systematically. We're going to do the back side of it. Back side, you see the direction is now become negative I now. Let me show you where that is. So this is the front, which we just did, and this side is the back. Back, you see the surface pointing out. So when you have a volume, when you have a subject, and the which side is out is clear. But if you just have an entire surface, not in a bulk material, so then it's not that easy to tell. If you have just a ring, which way you call the surface, it's difficult to call. But if you have a ball, it's easy to call. So now, here is x, in this case, x equals 0. So we plug it in. The main reason is we have dx, dy, dz. So we plug it in there before even do the integral. So this entire integral is give you 0. We do the same thing with the other part of it. So the other part, it is actually also very delightful in many ways. So this is the top part. Top part now, you see my surface normal becomes positive k, which is along the z-axis. Now, because this time my d sigma is dy, dx dy, so therefore my z is fixed now. So you can see here is fixed. If in the exam, if I know this happy, very happy, which is the cubic with 1, but if a z equals 2, so this won't be equal 0 at all. So then, so this essentially, I do not need to do anything because the integrand itself is already 0. The terms, the bottom part is a different story. Bottom part you can see becomes a negative direction, negative k direction, so that's you get a negative sign from this dotted product here. Now when you plug z, this won't be equal 0 because in the bottom part z equals 0. So minus parenthesis 0 minus 1, and this equals 1. Negative, negative become positive. So these two become positive. So that's what you get, a positive 1. And so here is repeating what I just said. Z equals 0, and your surface integral becomes dx dy, so the entire integral itself is just equals 1. Left, same deal, except now you can see along the negative y directions. You can also plug it in this case, we are lucky that this part is 0, otherwise we will have something remaining over here. For the right, same, and this time is positive z. So we add them up, this just equals 1 here. So you see, this is the brute force. We do the surface integral without using the divergence theorem. If you use the divergence theorem, and the results is 1 here. So therefore, these two results are consistent. There is no discrepancy here.